All right, so let's go ahead and get started. First of all, thank you everyone who has joined us this lovely summer day. Hopefully you're having better weather than we are in the Boston area, though it looks like it's stopped raining. So we are from Tufts University, the Center for Engineering Education and Outreach. I'm going to go over a little bit what we're going to do today, and then we can hear about the workshops that we're going to offer. So the first thing we're going to do is just introduce ourselves. There are three of us here. I'm going to talk a little bit about the center where we work, and then we'll go into the different professional developments that we are offering, and we'll have some questions. So my name is Alyssa Milto. I'm Director of Outreach at the Center for Engineering Education and Outreach, and we call it CEEO. And in that capacity, I do many things, but one of the things I do is oversee our workshops for students and teachers. Faye, do you want to go next?
Hi, I'm Faye Shaw, and I'm a postdoctoral researcher here at CEEO. And for the past 3 years, we've been developing a biomimetic robotics curriculum. And so we're excited to have some PD later this month.
Excellent. And Barbara.
Hi, I'm Barbara Bratzel. I'm a teacher at Shady Hills School and also do some work at the center.
Thank you. All right. So the center, we are located on Tufts Medford campus, and what we do is we do engineering outreach, tool development, and research. And our goal really is not to create more engineers, but to transform education through students and teachers' experiences doing engineering activities and the interaction that they get with the tools using research as a base. And as we do this, we're always trying to make sure that this is something that all students are able to access, all teachers are able to access, so that it's done equitably and everybody gets a chance at the same resources. All of our workshops for kids and for teachers, they're hands-on. So we really want to make sure if you're doing this, you're getting in there, you're having that learning experience to really see not only how it theoretically should work, but really getting a chance to play around with whatever tools you're using. And as you're doing this, of course, you're going to succeed at a lot of things and you're also going to fail. So you're going to go back and need to make some changes on what you built, which is exactly what the kids go through. So that as a teacher, we want you to have that experience that you're talking about the pedagogy, the technology, and how it works in the classroom, but we also want you to have a chance to fail and try and figure that out as you're learning the tools. We always keep our ratio of facilitator to participants low. We don't have very huge workshops because we want to make sure that everything is individually tailored, that we have time to answer questions about not only the tools, but your classroom. So when you leave a workshop, you have some understanding of how you want to implement this once you get to your classroom. So this summer, we are happy to have 2 workshops. The first is biomimetics that Faye is going to talk about, and then our Lego Engineering Institute. All right, so I'm going to turn it over to you, Faye.
Thank you, Alyssa. Like I said before, this comes out of 3 years of research. We've iterated over those 3 years. This curriculum is interdisciplinary and combines biology, engineering design, and computational thinking. We're hoping that by integrating this into biology, into life sciences, we can reach more students and have them exposed to robotics and engineering. A lot of time it's in a club or it's an elective and not all students have access to it. We've implemented this for 3 years in a row with 13 teachers, 9 schools, and then 550 students, both in the Massachusetts and in the Maryland area. We use the Hummingbird Robotics Kit for the students to program, and the curriculum is available whether or not you attend PD. And we also have resources on the Padlet site we have there. To look a little bit more at what the students are building, next slide, please. This is the kind of analysis that they might be doing. This is a picture of a pangolin, and it has these really large claws. And we look at these animal adaptations to address a earthquake disaster scenario, thinking about how digging is difficult for humans and robots, but if we learn from animals, this is one way to do it. And then the next slide has some more student work. And on the left is an early prototype sketch on one of our worksheets that the student is describing how they would build this, and this is a finished robot. So this whole series of pictures is one student group's design going through from animal analysis to idea to building.
Hey, can you tell everybody a little bit about what they'll be doing in the workshop as far as sort of the process, and then how you'll think about implementation in the classroom?
Yeah, so the professional development is 2 days. The early parts of the workshop involve that animal analysis and trying to look at the particular animal features for how animals dig. And we have video and text resources, and then we go through the worksheets of what the students do. And then there's a design phase, thinking what kind of materials the students might want to use, and of course, building along. And then we have a build phase, some of the end of the first day and a lot in the second day. And then reflecting, we are meeting with one of the teachers who implemented with us for 2 years, and then thinking about logistics and classroom management and these types of things.
Great, thank you. And I know I've done this with you a couple times. Could you just talk a little bit about the ease of using the materials? That was one of the things that surprised me the first time I did it, that, you know, within 15 minutes, I had something that was digging.
Yeah, we've taken this curriculum and made it into other sized activities. We've taken this is a 15-day lesson with the students programming and designing and programming. And we've also made this a kind of activity where you have the robots pre-programmed, and then you can look at making appendages to go on these. So it doesn't have to be quite everything, but in some activities we've done, we can make it shorter by pre-building for the participants.
All right, so go back. Does anybody, those are your slides, right? Okay, so make sure I didn't miss anything. Well, I'll stop for a second and see if anybody has any questions for Faye. Michelle, I believe, McGee, can you, so Michelle has a question. Oh, I can unmute you.
I just allowed her. Yep.
I unmuted. Michelle, do you want to ask your question, or you could put it in the
Yes.
chat?
How long was the class period?
Oh, Faye, you're muted.
About 50 minutes. And we implemented in one science class, it met every day. And then in several of our tech classes, they were twice a week. Yeah, so they about 50 minutes or so.
And what age group did you work with?
This is for middle school students, grades 6 through 8.
Okay, thank you.
You're welcome.
Thanks, Michelle. All right, so we will move on. Barbara, can you tell us a little bit about your workshop? And I can't remember if this is like the 4th or 5th year that you've done it.
If you count all the different platforms, I'm past year 20.
Well, for this specific one, no, for us. No, I know you've been doing, yes, Barbara has been doing work with Lego for a really long time. She and I actually when I first started working at the center, you were already working there.
For Spike, really this is only the second, I think. I think last year was the first year we did Spike.
And then the summers before that, we were doing.
It was EV3. But I must say, having seen all these robotics kits, Spike is my absolute favorite one. So I am very excited to be doing workshops with it. So for Spike Prime, we are going to be spending the week getting teachers to the point where they are ready to use Spike Prime in their classrooms. And that's taking you wherever you are. If you're a complete beginner with anything Lego, to people who are experienced with other Lego sets, to people who've done some work with Spike. So I very much want to meet people where they are and take them to where they want to go. So we'll do a lot of programming and building. We'll talk about how you manage all those pieces in the classroom, because there's a lot of little plastic pieces to deal with and a lot of technology. We'll talk about how do you teach with open-ended projects and how you integrate other subjects. And then we'll also talk about all the resources that are out there, both from Lego and from other people. what are they? What are the good ones? So that you're walking out with a suitcase full of things you can use. And I will also provide lots and lots of activities and materials as well. Next
And just
slide.
as a side, you've written several books using
Yeah.
Lego, so you definitely have a ton of activities that you can talk about.
So both in the workshop and in doing Lego in classes, I tend to start simple, and we will do a lot of simple things in the workshop, like the HEART program. So there is a built-in program that lets you run motors and sensors that is pretty awesome. So kids can get right to making their things run without learning any programming. We'll talk about that. We'll talk about how do you build a car that runs and works in 5 minutes. Okay. So we'll start with very simple things. Next slide. Okay. We'll go on to pretty high-end things. So we'll go through a lot of programming. We'll do events, loops, conditionals, operators, and then it's very much what the participants want to see. If you really want to learn about variables, I can help you with that. If that feels like a step too far, you can skip it. There'll be a lot of choice built into the workshop so that you can work on the things that are useful for you. Okay. And another choice you have is using Python. I have all the activities in both Word blocks and Python. So if you want to do some or all of them in Python, that's awesome. Okay. Next slide. Okay. We'll do a lot of simple mechanisms. I think this tends to be a hole in Lego's curriculum, that they have a lot of beautiful builds, but if you're just looking for the little pieces that you could use to build something, that isn't necessarily always there. So we'll go through some of those useful small mechanisms that you can use over and over again and how to do them. Next slide. We'll also talk about how do you do open-ended activities. This is a perennial favorite at the CEEO, which is making a robot that moves without wheels. And this is, I just want to show you 2 short clips of things that my 8th graders came up with this. If you could click the one on the left, I'm not going to show the whole thing. But so Ava and Elise made basically a Zamboni by putting the wheels flat on the ground. You can see a close up of it. Okay, that's fine. You can stop that one. Okay, and then 2 other kids who took a very different approach and used the 2 big plates that come in this set as legs. Okay. Next slide. Okay. We'll talk about things like gears. We'll do compound gearing and all the different types of gears. And we'll also talk about how do you take that and apply it. For example, make a fan, build a fan that makes a breeze, which means coming up with good blades. The little ones I have on my sample here will not work. But it also means gearing it up so that the blades move fast enough that you can actually feel a breeze. Next slide. And we will do lots of applications. How do you take these things that you've learned and use them to do intriguing projects for kids? For example, taking a familiar fairy tale like Rapunzel, which has quite a problem built into it because people are climbing up and down on Rapunzel's hair, which is really, if you're Rapunzel, not a good thing. So we'll talk about giving that to kids as an engineering problem and having them develop solutions. So they might want to use a gear rack, which I have in the middle here, to make an elevator. Or they may want to make a ratchet and pull and then have a program like you see on the right that uses the buttons on Spike, the right and left buttons, to go up and down. So it's very much helping them frame the problem, come up with the solution, and help them develop it. And we will do that as teachers so that you can help your students do that as well.
Oops. Not sure what happened there. Okay.
Well, that's it. So perfect timing.
All right. Thank you. So we're going to go ahead and have questions. I know that there was one that someone had asked Faye, if you just don't mind sharing that one.
Yeah, the question was how many students can use the Hummingbird Robotics Kit, and 2 to 4 is what I've seen.
Okay. And Barbara, do you want to talk a little bit about kits in your classroom as well?
Yeah, generally I have done 2 kits. I'm sorry, 2 kids per kit. This past year with the pandemic, we were actually doing single kits. So each child had their own kit. But I think the standard is 2, and 2 is, I think, is the optimal number.
Yeah, I agree. So I know that links to the workshops have been put in the chat, and Faye has put in some of the biomimetic resources that are free there as well. Let me see if we have any other questions. I don't see any. All right, so I think we will stop then. Thank you everybody for coming. If you have a question, still put it in there as we're wrapping up. Oh, I see. We don't know. Usually we just do the Lego one in the summer because it's a week and because Barbara teaches, so that would be very difficult for her to offer it at other times. And then this is the first time we've offered Faye's workshop, so hopefully we will continue to offer that as well. But yeah, honestly, we're just trying to get through the pandemic and the summer and everything and trying to figure it out. Our goal is to have workshops during the school year, but we haven't started talking about that yet. No other questions? All right, so I'm also going to put my phone number in the chat. Not my phone number, sorry, my email. So if questions come up.
So I see a question about missing a day in the Spike workshop.
Oh, no.
Not a problem. We can certainly catch you up and work around it.
Yeah, and so thank you, Barbara. I put please do the Tufts email and just put workshop in the memo, and I will make sure to answer any questions you have. All right, so we'll wrap up then. Thank you everybody for attending. Thank you panelists, really, really appreciate you coming and talking. And I know that you were both gonna have really exciting classes. We always get wonderful reviews back. So I'm sure everybody will have a very good time. So thank you so much.
Thank you.